Assalamualaikum and hello everyone. So in this video I'm going to teach you chapter 2.5 Stoichiometry. Okay, for your information, this syllabus is for SES syllabus, system 4 semester. Okay, and our learning outcome for today is you should be able to calculate the amount of reactant and product from a balanced chemical equation, and then the calculation will involve reacting masses and moles, volume of gases at room temp condition, and STP, and volume and concentration of solution. So I will just focus on learning outcome A for this video. Alright, so let us start with stoichiometric calculation. Stoichiometry can be used for calculating the species we are interested in during a reaction. Okay, so for your information, stoichiometry here actually referring to the stoichiometric coefficient in front of the chemical formula when you write down your chemical equation. So as you can see over here, 2 is the stoichiometric coefficient, like over here 1, okay, this one also 1, this one is also 1, the stoichiometric coefficient. Okay, so we can use the stoichiometric coefficient, okay, to calculate the data that we need. Okay, so the first example involving stoichiometric calculation involving reacting masses and moles. Okay, so let us have a look at example 1. So in example 1, dia tanya how many moles of hydrochloric acid, okay, and then needed to react with 0.5 mole of zinc. Okay, and then determine the mass of HCl. Okay, so let us write down the information yang kita ada. Okay, for example, we know that zinc here is actually 0.5 mole. While for HCl, the first thing the question asks is for number of moles. So I'm going to write N and then question mark. Okay, and then the next thing the question asks is mass of HCl. So that means after we have our mole, we need to find our mass for HCl. Okay, so there are two things lah we need to find. Okay, but before that we need to find mole. Okay, so just by using the data from zinc, we are going to get data for HCl. Okay, so by using stoichiometric calculation. Okay, so from balance equation, which is the equation given here, okay, 1 mole of zinc will react with 2 mole of HCl. Okay, so will react with, over here saya tak tulis lah will react with apa macam tu. Okay, so saya tak tulis macam tu. Instead saya just tulis simbol 3 macam ni lah, equivalence tu. Okay, so but you can also write down over here maybe ni react with ke. Okay, but it depend on the reaction. Okay, in this case since reactant dengan reactant, so that's why dia maksud dia macam 1 mole zinc react dengan 2 mole of HCl. Okay, so ini dari mana saya dapat? Okay, saya dapat dari stoichiometric coefficient dia, depan ni 1. Okay, and then untuk HCl depan dia 2. Okay, right, so settle daripada stoichiometric coefficient. The next line that we need to write here adalah line yang data yang kita betul-betul ada. Okay, so like this zinc here, actually kita tak ada 1 mole pun. Yang kita ada hanyalah 0.5 mole. So I will write down over here 0.5 mole of zinc will react with how many mole of HCl. Okay, so that is what we want to find lah. X ni, nilai X ni. Okay, so untuk dapatkan nilai X ni, kamu kena darab silang. Okay, sebab dia darab silang lah. So kiranya X ni akan darab dengan 1. And then 2 darab dengan 0.5. X darab 1 equal to X. Okay, and then for 2 times 0.5 is actually 1. Okay, so 1 mole of HCl. So that means if you have 0.5 mole of zinc, you will need 1 mole of HCl. Okay, untuk reaction tu berlaku. Okay, so kita dah ada mole of HCl. So basically kita dah menjawab soalan yang first. Dia minta number of mole of HCl needed to react with zinc. Okay, the next thing we need to find adalah mass. Okay, kita dah ada mole, nak cari mass. You should be able to remember there is another formula that relate mole and mass. And that formula is number of mole equals to mass over molar mass. Okay, so I will just plug in the value here. So mole, 1 mole HCl. Okay, mass of HCl itu yang kita nak cari. So I will write down mass of HCl. Okay, and then for the molar mass of HCl, hydrogen 1 tambah 35.5 jadi 36.5 gram per mole. Okay, so lastly, 36.5 gram per mole times with 1, so dapat 36.5 gram of HCl. So kita dah dapat dah dia punya mole of HCl yang diminta, dan kita dah dapat dah mass of HCl yang dia minta. So settle for example 1. Okay, so settle with example 1. Next I will go to try this question, but for this question I'm not going to discuss the whole working scheme, but I will just point out macam mana cara nak buat. Okay, so first the question asking for how many mole of H2O. So dia minta mole of H2O will be formed when 0.25 mole of C2H2OH burn in oxygen. Calculate the mass of water produced. Water here means H2O lah. So that's mean again for H2O there are two things yang dia minta. First number of mole, after that dia minta mass. Okay, so I will just write down there lah. Okay, and then the information given in this question is information related to C2H5OH, which is 0.25 mole. Okay, so information yang dia bagi untuk membantu kita cari pasal water ni adalah 0.25 mole of C2H2OH. So that's why saya tulis information dia bawah ni lah. Okay, so kita akan guna information yang dia bagi ni untuk cari produk dia. Okay, so kalau kamu perasan, the difference between try this question and this example 1 adalah example 1, dia data given is the reactant data, and then you want to find reactant juga macam tu. But for this question, dia bagi reactant punya data, and then the question ask for produk punya data. Okay, so dalam keadaan ini boleh. Okay, kita boleh cari guna reference daripada reactant untuk cari produk, boleh, tak ada masalah. If you have produk punya reference nak cari reactant pun boleh, as long as you can compare using stoichiometry coefficient tu lah. Okay, so maksudnya buat cara yang biasa macam atas ni. Okay, but kamu akan comparekan C2H5OH dengan H2O. Okay, so boleh cubalah. Okay, next, so let us discuss example involving volume of gases at STP. Okay, so this is the equation given, and then the question asks us to calculate the volume of oxygen at STP produced from 1000 gram of C4H10. Okay, so let us gather the information. So next one, we need to find the volume of oxygen gas at STP. So in order to find volume, the first thing we need is we have to find number of mole first, because from our previous lesson we know that in order to get volume we need to know number of mole, because number of mole equals to volume divide with molar volume. So in this case the molar volume is STP, standard temperature and pressure. Okay, so if you want to find volume, you need to have number of mole and STP first. STP memang adalah 22.4 dm³ per mole. For number of mole, you have to find number of mole first lah. So we need to find number of mole of the other reactant. Okay, sebab kalau kita tengok sini untuk oksigen kita dah tak ada apa-apa information about oksigen. So kita kena cari number of mole untuk C4H10. Okay, so kita kena cari number of mole equals to mass divide with molar mass. Okay, for number of mole of C4H10, the mass is 1000 gram, and then divide with the molar mass. The molar mass is 58 gram per mole. And the number of mole is 17.2414. Okay, I will take 4 decimal places since I need to use this number of mole in the next calculation. Okay, now we already have the number of mole. Okay, number of mole ada, STP ada. Okay, so that's mean kita boleh kira volume lah. As you can see over here, I already substitute the number of mole and the STP. Okay, and then we need to find the volume of oxygen. So volume of oxygen obtained here is 386.207 dm³. Okay, the unit is dm³ because this one per mole and mole can cancel out, so dm³ je lah tinggal. Ataupun if you don't want to write in terms of dm³, you can also write in liter. Okay, so macam tu pun boleh. Okay, and the final answer, since this is final answer, you have to leave it in 3 decimal places. So that's all for this example. Okay, so next let us try to solve example B pula. Determine the volume of carbon dioxide formed at STP by referring to A. Okay, so in this question, the carbon dioxide is the product lah. So soalan minta volume of carbon dioxide ni berapa. Okay, sama juga condition dia cakap at STP. Okay, so nak dapatkan volume, sebelum dapatkan volume kena dapatkan number of mole dulu, N dia. Okay, so nak dapatkan number of mole of carbon dioxide, kita tak ada apa-apa information about carbon dioxide. So maksudnya kita kena gunakan mole daripada reaktan ataupun produk yang lain lah. So dalam kes ni kita ada mole of reaktan yang awal ni, yang C4H10. So kita akan guna mole yang ini untuk dapatkan mole of carbon dioxide. Okay, tapi kita kena compare stoichiometry lah. Kita compare dulu dia punya stoichiometric coefficient antara C4H10 ni dengan CO2. So from balance equation, 2 mole of C4H10, okay, 2 sebab depan ni 2, okay, produce 8 mole of CO2. So 8 ni dari sinilah, okay. So the first line ni daripada dia punya stoichiometric coefficient sahaja. Okay, and then kita masukkan mole of C4H10 yang sebenar-benarnya yang kita ada, yang kita calculate dekat part A tadi, iaitu 17.2414. Okay, so kiranya kalau 2 mole of C4H10 menghasilkan 8 mole of CO2, itu dari equation. Tapi mole yang kita ada besar, tu 17.2414 mole of C4H10. So berapa mole of CO2 yang terhasil? Okay, so for this part again kita akan darab silang. Okay, so bila kita darab silang tu kita dapatlah nilai X. So X tu darab dengan 2 dari 2X, 8 darab dengan 17.2414, 137.9312. Okay, so cari nilai X lah. So we need to divide with 2. Then kita dapat 8.9656 mole of CO2. So maksudnya dekat sini, kalau kita ada 17.2414 mole of C4H10, kita akan hasilkan 68.9656 mole of carbon dioxide. Okay, so kita bukan nak cari mole kan tadi. Ingat balik, tujuan kita nak cari volume at STP. Tapi kita tahu nak cari volume kena dapatkan number of mole dulu. So number of mole kita dah dapat. So next kita cari dia punya volume. So number of mole equals to volume bahagi molar volume tu kan 22.4 tu. Okay, so kita pun substitute lah dalam formula ini. Okay, so number of mole 68.9656. Okay, so volume of CO2 is the one that we want to find. Okay, and then the bawah ni 22.4 dm³ per mole. Okay, so volume of carbon dioxide kita darabkan, dapat 1544.829. Okay, kita tinggalkan jawapan dalam 3 titik perpuluhan. Okay, and then dia punya unit dm³ sahaja sebab mole per mole ni cancel out. Kalau kamu tak nak tulis dm³ macam sebelum ni, you can also write in later. Okay, so I think that's all for example B, and basically done lah for this example. Okay, stoichiometric calculation involving volume of gas at STP. Okay, so next let us go to example involving volume and concentration of solution. Okay, so question dia kata how many milliliters of 0.112 molar of HCl will react exactly with the sodium carbonate in 21.2 ml of 0.15 molar sodium carbonate according to the following equation. So this is the equation, and as you can see the equation dia dah already balanced for you, so no need to balance. Okay, and then next thing kita kumpulkan information yang ada. Okay, itu saya punya style lah supaya saya nampak lebih clear. Okay, so 0.112 molar ni adalah concentration untuk HCl. Okay, so that's why saya tulis bawah ni lah. Okay, concentration tu maksudnya molarity. Okay, so M. Okay, so kalau macam mana nak tahu dia molarity ke tak, kamu tengok unit. Okay, kalau unit M tu maksudnya molarity punya unit. Okay, right. Lepas tu dekat sini dia bagi kita volume 21.2 ml. Ini adalah sodium carbonate punya. Okay, and then 0.15 mol ni adalah concentration untuk sodium carbonate. Okay, lepas tu soalan tanya berapa milliliter of HCl. Milliliter of HCl maksudnya itu adalah unit kepada volume of HCl. So soalan ni dia minta volume of HCl tu berapa. Okay, so hopefully by now kamu sedar lah. Okay, nak cari volume kita kena cari mole dulu. Okay, so now our aim is we want to find number of mole of HCl dulu. Okay, so kita akan cari number of mole of HCl menggunakan number of mole yang sodium carbonate ni. Okay, untuk sodium carbonate ni, as you can see, data given adalah molarity dan juga volume. Okay, so sepatutnya by now kamu dah think dalam fikiran kamu lah. Okay, number of mole equals to molarity darab volume. So maksudnya kalau kamu darabkan dua nilai ni, kamu akan dapat number of mole of sodium carbonate. Okay, so kat sini N equals to MV. Okay, number of moles sodium carbonate, concentration sodium carbonate darab dengan volume of sodium carbonate. And as you can see, the volume here saya ubah. Okay, so ini dalam ml, ini dalam L. Sebab kalau nak pakai N equals to MV, okay, so ini mesti dalam unit liter. Okay, so macam mana nak tukar liter? ml bahagi 1000. Okay, so dapatlah 0.0212 liter. Okay, so molarity darab volume dapat mole. Okay, so once kita dah dapat number of mole, kita boleh start compare dia punya stoichiometric coefficient lah untuk dapatkan mole of HCl. So from balance equation, 1 mole of sodium carbonate, which is this one, will react with 2 mole of HCl. So that's why sini 2 mole of HCl. Okay, so equal ni sekarang maksud dia will react with 2 mole of HCl in this case lah. Okay, so macam biasa bawah ni kita masukkan mole kita yang sebenar-benar untuk sodium carbonate, and that is this number of mole lah. Okay, so 3.18 eksponen negatif 3 mole of sodium carbonate ni akan react dengan berapa mole of HCl. Itu yang kita nak cari. So macam biasa darab silang. Saya dapat X equal to 6.36 eksponen negatif 3 mole of HCl. So maksudnya 3.18 eksponen negatif 3 mole of sodium carbonate ni akan react dengan 6.36 eksponen negatif 3 mole of HCl. Okay, so mole of HCl dah ada. Next kita cari dia punya volume lah. Okay, so saya dah masukkan dalam formula nilai-nilai mole yang saya dapat tadi masuk dalam formula volume ni, and then darabkan je lah. Okay, so volume 0.1425 dm cube. Okay, dm cube ni dia macam dia macam L lah sebenarnya. Okay, so kalau saya tak nak tulis dm cube, saya tulis L. Okay, so bila L, soalan minta tadi, dia minta dalam mililiter. So maksudnya kalau ada yang tak sedar, dia kena convert ke liter tu kepada mililiter, dia akan hilang satu markah lah. So kena darab 1000 untuk tukar kepada mililiter. So dapat 142.464 milliliter ml. Okay, so that is our final answer. So I think sampai sini kita settle lah learning outcome kita yang A. Okay, so kiranya banyak dah calculation yang saya tunjuk yang berkaitan dengan stoichiometric calculation. Okay, thank you, bye.